So I've got the various parts of the PMC-101 Micromate CPM computer here. It's an 80-based machine. You've looked at it in the previous couple of videos. There was a lot of video shot between the second video and this one, and I've lost all that video. Troubleshooting of the original power supply, which I still haven't got working. I'm just not sure why. The 12-volt rail on it under anything more than about 100 milliamps collapses down to 0.37 volts. It's an LM317 based regulator. The input voltage collapses too low and the regulator can't regulate, and the output basically drops down to that 0.37 volts, and I cannot figure out what earlier in the power supply is happening. It just doesn't make sense. I've replaced pretty much every component and haven't got there yet. So instead I'm going to substitute in this Meanwell. It's an RT65B. It's a heftier supply, plus 5 at 5 amps, plus 12 at 2.8, and minus 12 at 0.5. All three voltages are required. The floppy drives require plus 5 and plus 12. The board itself requires plus 5, plus 12, and minus 12, and the plus and minus 12 are for the 1488s and 1489s here that are the RS-232 line drivers. There's, of course, the Z80 CPU. There's a, I believe it's a CTC sitting here. Yeah, CTC counter timer clock chip. There is a dual UART here. It's the MOSTEC part, but I believe it's the dual UART. It's two full UARTs that Z80 uses. There's the little boot ROM over here that's 2732. There is an FD1778 or 79, I believe, down here. Is the floppy disk controller. It's an FD1797B-02. Floppy disk controller, the cable here that controls floppy disks, external floppy drive connector, external parallel connector, and there's two pin headers here and here that pick up the RS-232 and bring them to the back of the case on these connectors here, over here. I've got this out of the case at this point to talk a little bit about the troubleshooting. So on the original power supply, the system ran for a short period of time, probably less than an hour total, and then the floppy started having all kinds of issues. And at some point I noticed the floppy drive was running slow, and I actually thought the drive had failed. I didn't check the power rails at that point, and I didn't realize at that point the plus 12 volt rail was collapsing, was failing in the supply, and I did a whole lot of swapping floppy drives and scratching my head and real confusion, and finally checked the power supply rails and went, wait a minute, the plus 12 is not there. Found an RT65B in my collection of switching power supplies, hooked it up, system wouldn't boot, wouldn't run on it. Checked the voltages a whole bunch of times, total confusion. That RT65B I had repaired, I dug around, didn't have another one. I finally jumped onto Amazon and ordered a fresh one, and the same issue, the system wouldn't boot on it. And that led to all kinds of confusion. And finally, on Twitter, I actually posted something and basically said I'm replacing a switching power supply from the early 80s with a modern one. System doesn't boot after anybody have any ideas. And I think it was Glitch from Glitch Systems LLC who posted and said the system clock may be running at the wrong rate because the switching power supply is much higher frequency than the one from 82 when this was built. And it may be that your CPU clock is starting at the wrong frequency. And so I dug out the schematics, I'll blow up a section of it for you here, and found the system clock generator, and there's just a standard 4 megahertz crystal, which is sitting here, an LSO4, really standard configuration here, to get a 4 megahertz clock out, and then there's an LSO4, basically driver, that creates the 4 megahertz clock for the CPU, and creates, I think this clock is used by the CTC, but I don't remember. Power the system up, take the scope probe, get down here and touch ultimately pin 6 and notice that the clock is running more like 16 megahertz. The clock is running way too fast, and I start probing back through, and it's obvious the clock isn't syncing correctly. And at some point with the probe on pin 4 here, I powered the system down and powered it back up, and it started at 4 megahertz and it suddenly acted normal. And I was like, oh, that's interesting. And knowing that the probe adds about 20 picofarads load itself, I went, huh? And so I verified that a bunch more times, tried other points. This seemed to be the magic point. So I just added a 20 picofarad capacitor from that point to ground, which is the little orange guy you can see sitting on top of here. It's not a great job putting that in there, but that's what I ended up with. So that 20 picofarad capacitor, turns out, gets the system started up every time nice and solid. The clock wakes up and grabs 4 megahertz and produces a nice 4 megahertz, and I get a nice 4 megahertz, 50% duty cycle clock down here. It's just very, the clock's very stable at that point, and I'm very happy with it. But that was the fix, and I appreciate Glitch mentioning that, because as soon as he said it, I went, yeah, I knew what this was, but it didn't click. It just didn't work in my head. So the second issue I had with the system all along was it didn't always do power up reset. I'd have to manually hit the button here on the front and reset it. Sometimes it would, sometimes it wouldn't. On the mean-wall switching supply, it never reset on power up. I had to manually reset it every time. And so I went back to the schematics, did some digging, and found the part of the schematic that generates the reset. And there's a couple of different parts here. There is this switch on the front panel that's got a common and normally closed and normally open. And this is a debounce circuit. All this does is debounce that switch. So when you hit reset, you get a very solid low drive, held low, and then when you release it, back up to 1. There's no bounce, there's no anything. It makes a really nice little debounce circuit. But at power up reset, you've got this combination down here. It's got a 4.7 microfarad electrolytic and a 10K pull-up resistor. And what happens is when you first power the system on, this capacitor is discharged. And it takes a little bit of time for that capacitor to charge. There's, the RC resistor capacitor time constant here, and it takes a little bit of time for that capacitor to charge up close enough to 5 volts that this gate will switch and the reset pin will become high. And this wasn't delaying long enough. And so I found the little 4.7 microfarad capacitor sitting down here. It's the axle lead one on the board. And I just tacked a 10 microfarad electrolytic across the top of it. It's kind of a lousy job. I'm not happy with either one of the capacitors I've added here, but it is what it is. And now I get a really solid reset on power up. System comes up, it does its thing, and it's just ran really solid. So the video where I troubleshot all this is gone, and I apologize. So this is my best explanation of what went on. Noticing the scope on power up would clean up the clock here. Like I said, scope probe has, I think mine has about 20 picofarads capacitance. Someplace in there, adding a 20 picofarad cap, solid as rock. Taking it from 4.7 to about 15 microfarad total capacitance. So the power on resets 3 times longer. It's holding reset low about 3 times longer was enough to get a really solid restart. So I've got the board out at the moment. There's the work I did down here, like I say, that I'm really unhappy with what I did, but it's in there, it works. I was going to clean it up, and I've decided not to. I also added, while I was in here, these little jumper links here. They're just resistor leads. These pick up ground, and so when I was probing in here, I was able to attach the scope probe directly to here and get a pretty short distance between the ground that the probe was on and the signal I was probing. I may have actually even had one here I removed, I don't remember. And I added one up here on the +5 rail for a logic probe, so I can hook a logic probe up between these 2 points. So rather than trying to find a capacitor lead or something to clip onto, I just find power rails normally and add little jumpers for debug. The main system power comes in on this cable. Orange is +12, purple is -12, there's ground and there's +5. I really don't think this is a great way of bringing power on. The angle here is how I received the board. I have reflowed these just to make sure they've got good contact. It just kind of hangs there. There's no double-sided tape. There's nothing to act as kind of reinforcement, and it's weak. It is what it is. But there's these that go off to the switching power supply, and then floating around here is the lead for the internal floppy drive, and it of course picks up +5, a ground, and +12. So it does follow the red +5, orange +12 color coding. So what I want to do in this video is get this board remounted into the system, get the power supply reconfigured, or reassembled, the leads onto it, get it installed, and we'll look at booting. Other things to mention. See, that's not, so the original drive that came out of the system doesn't seem to be aligned correctly. So I had real issues. So I used IMD on my 46 machine to image boot media for the system. And the original drive, it was really intermittent whether it was going to boot or not, or work or not. And I discovered when I could get it to boot, formatting disks in that drive generated errors in other drives I've got. So I think that original drive was out of alignment. I've been using this drive as the main boot drive on the system, but again, there's just something weird about alignment, or I just don't know. Yesterday in the mail, I received these drives. I'm really happy with these. These are Mitsubishi M4851s. This is a 360K drive, double-sided, double density. It is built like a tank. It's really solid. It's got an actual head load solenoid over here, like 8-inch drives had. So it actually does a head load for read writes, and then releases the head, so that you're not creating wear on the media. It's got an interesting latch system on the front where the media goes in. In this case, it's the shipping disc, but the media goes in and clicks into place, and then you pull the latch shut, and then you push the button in to release it. Works really well. I got 2 of these. It was a good price. The seller had described them as nice. I'm not 100% sure they're not new old stock. The scratches here kind of say okay, maybe a little bit of use. Super clean. I haven't even lubricated them. It's so clean. The only thing I ran into is one of these got a little bit more motion in shipment than it should have, and it bent some of the pins up a little bit, and I've just realigned the pins. It's no big deal. But 2 of these, they have both been used on my 486 machine to format both 360K DOS floppies and to format CPM boot floppies for the PMC-101 here. They just work solid as a rock. They're nice and heavy. It's a cast frame. It's not the cheap stamped steel or aluminum that the really inexpensive 1.2 megabyte drives eventually became. Really happy with these, and like I say, in both of them, I've formatted discs and stuff on the PC, and it's worked really well. So I want to install one of these in here to see if it'll go, and I've created 3 different bootable images using IMD that hopefully the machine should boot from. They're the images I've been using all along. So with that long preamble, let's go ahead and put parts back in. Actually, the other thing I need to check is before I started this video, I drilled an extra hole here and here to mount this power supply. I, however, have not checked for alignment. It looks like we're going to be okay. I used a piece of blue tape, stuck on here and trimmed down to the size and marked the holes, etc. to do that. So it wasn't a big deal to do. It looks like those holes are going to be okay. So let's go ahead and get this board back in. This is a little bit of a pain to do because all the cables kind of hit each other, intercept down here below. It's kind of hard to get up underneath this cable and get things to align. There we go. Okay. The original screws for these had tiny little washers on them, and where the slotted are the same ones I'm putting back in here. I'm sad I lost all that video. It is what it is. I have been able to run the system for extended periods of time in MS Basic for CPM, just opening files and reading and writing to the disks over and over. So on a different set of videos here are those dual 360K floppy drives in case that I bought, that we've been doing kind of a a repair cleanup. Oh shoot, the washer came off on. And those work really well with this. Those drives are currently headed down to Glitch LLC. They should get there Monday. Today is Saturday. To be serviced and aligned. I just didn't feel like aligning them myself. So I could have potentially done it. Why am I not finding a washer? That one has its washer with it. I'm sure the washer was over here. Doggone it. There it is. Don't want a loose washer floating around in here. That's just begging for disaster. So like I said, those are headed down. That was another conversation that occurred on Twitter where I had gone to, I think Farrell is the company, M. Farrell, something like that, who supposedly does drive alignments. I emailed the email address to ask about pricing and services and never heard back. I don't know what the tapping noise is outside. Posted on Twitter, and he got back to me. I've followed him for a while, and I think he follows me as well. And so we'll see. Hopefully I'll get a nice set of drives back. So there's actually 3 of the Tandon TMA 100, I think it is. 360K double-sided, double-density, full-height drives I sent down. The 2 that came in that dual drive case, and then the another one I bought from the same vendor I also got these drives here from. So I bought 4. I bought these 2 drives. I got a Mitsubishi, the same series, new old stock. It's a 4854, I believe, so it looks a lot like this, but it's 80 track, high density. It'll do high density, so 1.6 megabyte, 1.2 megabyte usable floppies. Built like these are, built like a tank, extremely strappable. It was new old stock that I picked up from him, and I could see there was an adapter cable with it, and there was enough notes there to know it was meant for a Heathkit machine. And when it got here, and of course there'll be a video about this, discovered that was a replacement drive for, I want to say, a Z1000 or an H100 or a Z100 machine, and it was meant to replace an 8-inch floppy drive with the 5 1/4 inch high density. And it even included notes on how to set the jumpers on the drive to act like to be seen as an 8-inch drive. And it's got an adapter cable that does the 8-inch interface to 5 1/4 inch interface. New old stock. It works really well on my DOS machine. I've formatted floppies. It's in excellent shape. Very, very similar to these 2 guys here. So I picked these 2 up. I picked that drive up, new old stock from him, and I picked up a used Tandon TM100, I think, and a 360K full height, kind of like is in that chassis we've been working on the other video series. Just so there was a 3rd one. So happy with that. So the board's back in. Let's hook up the reset switch here. Try to get this back in frame. I've got the camera up about as high as I can get it. Get the power LED on. This picks up its serial stuff here. This one sits over the top of it, and this goes to the floppy, but I'm not going to put this one on until we get the power supply put back together. So I've got the cables here. I have done this a whole bunch of times, and it is a pain. There was a point when I was trying to repair the original supply that I ended up using my bench supply to run the system. And on my bench supply, the system, they're linear power supplies. They're not switching. They're Rigals. I'm using a DP832 to get really clean, plus minus 12 and plus 5. Nice linear supply, really well. And the system just ran solid as a rock for days on that really clean power. From that, I was able to measure the actual current consumption, that kind of stuff, because of course the system displays it, and get a good idea of what I needed. And the RTB or the RT65B here is overkill for what I actually need. It is beefier, than is required, but that's okay. I really have no problem with that. It's better to be beefier than required. Let me get the 2 grounds. Let's see, common is here. And get both of these in. This is the same way this was done on the original supply, as these were both put in like that, connected together. It sits down. We have the 2 reds. So we're using this one as the downward facing. And the red on here as the upward facing. The purple picks up, actually let's do it last. We have the oranges, which are plus 12. To be consistent, I'm going to keep this one as the downward facing. So V2 on here is marked plus V2, and we see V2 on the side over here is plus 12. So that goes there. Let's kind of get this a little bit cleaner. And then we have the single purple, which goes to V3, and V3 here is minus 12. So I've put this together a bunch of times. I'm still going to verify it, however. I don't know if the previous videos captured me cleaning this or not. I mean, I've cleaned the inside of this. It was really clean to begin with, but kind of gone through it. Did a bit of cleaning. We've got the line cord coming in, and of course the line is switched. I'm in America, so black is the line, white is the neutral, and green is the earth. So let's get the earth hooked up here. Neutral. And black being this one's a little bit funky to get in here, a little bit tight. And of course the black here is going through the switch. It is the line. Why isn't that fitting in there? It's fit in there before. There it goes. It's just really, it's a little bit too wide. I'm gonna add a little bit more torque to all of these now that everybody's together. Just make sure nothing is hooked up except leads. I want you to just sit there. Let's get a voltmeter and verify before I apply power to anything. Last thing I need to do is have something swapped here because I've misread something and blow things up. So there was ground for the floppy drive. I think the power is currently off. Power's on. The LED on the supply is lit. I should see plus 5 here. 5.1 is fine. Plus 12. 11.78 is actually fine. It's close enough. The cable that goes to the system, there's the black lead. We should see minus 12. Minus 12.1 is fine. Plus 12 should be that same 11.78. And plus 5 should be the 5.1. So all of that looks fine. Power supply looks absolutely fine. So I'm pleased with that. We got everybody connected in the right positions. At least I think we did. I hope we did. This is a little bit tricky to work into place here. The first thing I want to do is hook the system power up, because it's really hard to get to with the power supply in place. You can see this is kind of a, you know, it works. It's just a really kind of odd way of mounting things, and then he needs to slide way back here tight to that position to be mounted. So future Neil here, I've edited a large chunk of video out here. I'll talk you through what I did. The switching power supply was removed. I stripped it all the way down, and I drilled a clearance hole so that the screw that holds the foot on had clearance. The screw was jutted slightly inside of the case, and it needed a hole for clearance. So that was taken care of. Both of the mounting screw holes on the power supply itself stripped out. It's an aluminum base. They were punched in aluminum, and I think I used too small a screw when I managed to strip them. So I found a couple of slightly larger diameter screws, and I just used those screws to tap new threads into the power supply. So there was a whole lot of video of me putting it together and taking it apart, putting it together and taking it apart that I've just removed. That's what happened at that point. So anyhow, let's pick this up now that I have the power supply pretty much put back together. Earth to earth. Neutral to neutral. And live to live. It's actually marked L on the supply. Line actually is what the L stands for, not live, but it is the hot lead. It's the live lead. That's why it's the one that's switched. The neutral lead is in essence a ground, not to be confused with the earth lead. It's return, whatever you want to call it. So there's a bunch of things I can call it here. I'm pretty sure I hit all these. Just double check. System power again. I really hate how that's done. Floppy power comes forward. This makes a big old mess that I just don't appreciate. It's just crazy ugly how that all goes together. That's there. And we took this one and in effect cut new threads in it. It's just turning into aluminum, so I think it was this one. Why can't I get you to, was it this guy? Well, it wasn't this guy, but it is now. Hopefully I'm not generating little bits of metal in there. They're going to short something out. What a total pain. This ply isn't in straight. It would be straight if I used the other screw. Does it need to be straight? No. Do I want it to be straight? Yes. Oh, got it. There it caught. I don't know why it wouldn't start before. Okay, that should be in a little straighter, and it is. That looks a little nicer. Let's I I guess take the original drive that was in here. For now, let me take the little screws off. The foot, that's why it's so unstable at the moment. We did all of this to get the foot to be able to mount correctly. Yep. Slotted screws for the feet, of course, because you know why not. So why aren't you sitting flush? Why is this foot? What the heck? Where's the slot? Where's the slot? Why is that foot sitting weird? Oh, the washer's missing. That's why. There's the washer. Shoot. Some days, man. Hopefully it's now sitting flush. That's much better. So, right cables to the board, floppy's hooked up. It's strapped as drive 0. It's the one that come out. I should be able to plug in, power on. And I already know the system's working. And I don't know if I'm going to be able to get this on camera or not. If you watch the power LED here, or the access LED on the floppy drive, you'll see it blinking. Hopefully that's coming in through on camera. And that blinking is it pulling the drive to say, is there a floppy, is there a floppy? And if I take one of the floppies that'll boot in this drive and stick it in, nope, it's got a bunch of read errors and failed. That's what the tick, 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 tick was. At this point, it's really best to power off and back on. I'm hoping these drives are going to be... Okay, that's booting. Yep, that's the normal sounds this thing makes when it boots. So it just booted up. I'm going to need to get a serial cable on it and get it hooked up to a terminal. I just haven't done that yet. So let me unplug it. I'm going to go ahead and pull this drive off. It's not the drive I intend to use at this point. Let me strap this as drive 0. It's currently set as 1 because it was on the end of a twisted cable. And a PC to make it drive 0 because, you know, PCs are weird. And have to do the whole little drive twist or cable twist thing. I mean, I get why they did it. It made assembly much easier. We have power. Actually, I guess I should make an attempt to see if it boots first. That might be a really good idea. So I guess the first thing is just to power it up and see if we get the blinking access, which we do. Let's try the disk that booted a second ago on the other drive. And nope. Nope. See, I think that drive has alignment issues as well. There's two drives floating around here in the shop that were reclaimed out of an old system. So these 3 floppies were created in either this drive or the other one. I'm going to assume all three of them should be bootable. They're different images. Up. That's exactly what I would expect to see. And we are booted. And the head unloaded. Oh, that's perfect. That's exactly what I wanted. So let me power this down, put the screws in, and we'll watch that together. That's exactly how I wanted this to work. That's just awesome. Get the little transport cardboard back in, just to protect the drive a little bit. Get this rotated. I'm trying to keep the board from falling down onto the PC board down below. Can I get that screw to catch? Can I get that lucky? Is that the right location? It is. And that one's caught. Most excellent. Let's go ahead and boot it sitting this way so you can watch the heads. So of course the head assembly here, the little bar here is the head load. It's still plugged in. Let me power on. I've got the blinking access LED on the drive. And of course the system power LED is on. Close the drive. Head's loaded. You can see it stepping here as it brings in the various parts of CPM. It's such a quiet drive. And head unloaded. It is booted. I have no doubt that it's booted. That is really nice. I'm going to cycle the power here. Even though these are all the same version, well, they're not all the same. Well, they're not all the same build of CPM. Let me put it that way. One of them has hard disk drivers on it, that obviously don't make sense here. That's probably this disk. Maybe that other one. I don't know. One of these has hard drive drivers on it. I believe that booted as well. That acted pretty normal. I didn't get the thump as it tried to rewrite or reread over and over and over. You know, retries. Yeah, I think that first disk is the one that had the hard drive drivers on it. And this one is an image I created that I'm having trouble writing back, and I'm not sure why. So I'm not surprised this third one isn't starting, honestly. I believe this to be that this one should have MS Basic on it. Hit reset, close it. Yeah, I'm pretty sure this is the one with Microsoft Basic on it for CPM. Need to hook a terminal up next, but we are bootable. And like I say, I suspect this drive has, hopefully it's got good head alignment. I'll know when I get the drives that are being aligned back. Some scratches there. You know, if these were used, they were well taken care of. You know, maybe removed from the original system they were in. But just really clean. They haven't come to me just full of dust and nasty and... So, what else to hit in this video? Is there anything else to talk about here? We've got everything reassembled. If we have the drive in here, I hope to use with it. I just like the fact that it actually does the head load. You know, it is an early 360K half-height drive. So I believe it's an early being a Mitsubishi. I don't really know when it was manufactured. I didn't really look for date codes. I don't know date code. Not seeing date code. 12th week of 84, so it was made later than I think. This guy here, 12th week of 84. So, just seems like a really nice solid drive. So, very happy with it. I think I'll wrap this one up here. We will play with this guy further when I can do screen capture of the terminal session. And I hope to see you in those videos. We'll talk soon.